Hello everybody, and nice good morning to all of you. In previous video, we have discussed regarding the objective questions of paper 1 of SSCG till question number 35. Now in this particular video lecture, we will continue the next question, that is question number 36. Now in this particular question, this is basically a semiconductor has a band gap of 2 electron volt. The wavelength of radiation emitted from the semiconductor when electrons and holes recombine is. Now first of all, we have to calculate these by using the formula of energy radiated. Now let's calculate basically. Now as we know, the value of energy radiated, which is basically denoted by Eg, is equal to hc by lambda, where lambda is basically wavelength, h is basically Planck's constant, whose value is equal to 6.63 into 10 to the power minus 34 meter square kg per second, and c here is basically a speed of light, which is equals to 3 into 10 to the power 8 meter per second. Now if we put all the values, now here Eg is basically given in electron volt. First of all, we have to convert it into joule. Now to convert it into joules, we have to multiply by 1.6 into 10 to the power 1.6 into 10 to the power minus 19 joules, 10 to the power minus 19 joules. Now as we put here all the values, then the value of lambda will be equals to 625 nanometer. After putting all the values here, that is here in the question, the value of Eg, that is energy radiated, is given, which equals to 2 into 10 to the power 2 into 1.6 into 10 to the power minus 19 joule, and here the value of H, that is Planck's constant, is given, that is 6.63 into 10 to the power minus 34 meter square kg per second, and the value of C is also given here, that is 3 into 10 to the power 8 meter per second. Now as we calculate here lambda will be equals to hc by Eg. Now as we put all the values, we will get the value of lambda is equals to approximate 625 nanometer. So here the value of lambda will be equals to 625 nanometer. Now the second question, here the correct answer will be option A, that is 625 nanometer. 625 nanometer. Now the next question is resistivity measurement are often used to determine. The first option is carrier concentration in intrinsic semiconductor. Option B, carrier concentration in extrinsic semiconductor. Option C, lifetime of polycrystalline materials. And D, none of these. Its correct answer will be option B, that is carrier concentration in extrinsic semiconductor. Now the next question, that is 138 number. The drift velocity of electrons in silicon is option A is proportional to the electric field for all values of electric field. Option B is independent of the electric field. Option C is increases at low value of electric field and decreases at high values of electric field, exhibiting negative differential resistance. And option D is increases linearly with the electric field at low values of electric field and gradually saturates. Option D is right answer. Now if we draw its graph, then the graph basically comes some like this, means for lower value of E, we can see here that VD is basically proportional, and as we increase the value of VD, as we increase the value of E, then basically VD becomes saturate. So here the correct answer will be option D. Now the next question, that is 39 number. When an electron breaks a covalent bond and moves away, option A, the semiconductor becomes conductor. A vacancy is created in broken covalent bond. Option B is correct answer. Now the next question, that is which of the following has least number of free electrons in it? Its correct answer will be option D, that is insulator. Now the next question, which of the following is a trivalent? Its correct answer will be option D, that is all of these. Its correct answer will be option D. Basically all of these means boron is also a trivalent atom, aluminum is also a trivalent atom, indium is also a trivalent atom. So its correct answer will be option D, that is all questions, all options are correct. Now the next one is which of the following are immobiles? Its correct answer will be ions, means at the junction the immobile ions are present at the junctions, and that ions are basically immobile in nature, means they cannot move. So here the correct answer will be option C, that is immobile. Means in if we talk then in depletion region there are acceptor and donor ions, basically they are immobile or fixed. Now during the formation of p-n junction, electron leave behind an immobile positive ion, and donor ion we can say on n side, while holes leave behind an immobile negative ion or acceptor ion on p side. So here the correct answer will be option C, that is ions. Now the next question is the conduction band is option A, the region of free electrons or range of energies corresponding to the energies of the free electrons always above the forbidden energy level. Option D, concentrated holes for the flow of electron. Its correct answer will be option B, that is a range of energies corresponding to the energies of the free electrons. Now the next question, the process of adding impurities to a semiconductor is known as doping. Its correct answer will be option D. Now the next question is which of the following has the highest mobility? Its correct answer will be option B, that is electron. Now the next question is which of the following is a tetravalent, means having 4 valence electron? Its correct answer will be option C, that is germanium. Now the next question, the acceptor type of impurity. Now here the correct answer will be both option B as well as option C. Now the next question, that is the impurity to extrinsic semiconductor is of the order. Its correct answer will be option C, that is 1 in million. Now the next question is which of the following element belongs to the same group of periodic table as that of silicon and lead? Now if we talk regarding its explanation, then basically silicon is a member of group 14 of the periodic table. Now the same group as that of the carbon. So here the correct answer will be option B, that is carbon. Now the next question is the merging of a free electron and a hole is known as recombination. Its correct answer will be option A, that is recombination. Now the next question is the germanium crystal behaves as an insulator at its correct answer will be option A, that is 0K, means absolute 0. At absolute 0 the germanium crystal behaves as an insulator. Now the next question is 52 number, which of the following material has a large number of free electrons? Its correct answer will be option C, that is conductors. Now the next question, which of the following material has lowest resistivity? Its correct answer will be option A, that is conductor. Now the next question, that is when an electron is removed from an atom it becomes, its correct answer will be option D, that is ionized. Means its correct answer will be D, that is ionized. If we talk regarding its explanation, then removing an electron from an atom, more if you remove an electron from an atom, then more proton will be there in the nucleus than the number of electron, therefore it becomes positive ion. So if you remove an electron from an atom, then it becomes positive, means it becomes ionized. So its correct answer will be option D, that is ionized. Now the next question is the donor type of impurity. The donor type of impurity is basically, its correct answer will be option A, that is phosphorus. Now the next question is at absolute 0 an intrinsic semiconductor, option A becomes superconductor, option B disintegrates, into pieces. Option C, behaves like an insulator. Its correct answer will be option C, that is behaves like an insulator. Now the next question, the conductivity of silicon can be expected around. Its correct answer will be basically option B, that is 0.5 into 10 to the power minus 3 Simon per meter. Its correct answer will be option B, that is 0.5 into 10 to the power minus 3 Simon per meter. If we talk regarding its explanation, then silicon is basically semiconductor material, and its conductivity is of the range 0.5 into 10 to the power minus 3 Simon per meter. If we try to find its conductivity, then as we know, the reciprocal of resistivity is known as conductivity. So if we try to calculate its conductivity, then we have to use the formula, that is conductivity is equal to 1 by resistivity, and the resistivity of silicon is 2.35 into 10 to the power 3 ohm meter. Now if we calculate, then it will basically comes around approximate equal to 0.5 into 10 to the power minus 3 Simon per meter. Now the next question is, which of the following material has the highest resistivity? Clearly it is visible from here that option A, that is insulator, option A. Now the next question, that is the number of valence electron of phosphorus and silicon are respectively. Phosphorus, as we know, phosphorus has 5 valence electron and silicon has 4 valence electrons. So its correct answer will be option D, that is 5 and. Now the next question is, which of the following impurity is to be added in pure germanium to obtain p-type semiconductor? Its correct answer will be option D, that is gallium. Now the next question, that is in silicon dash energy must be supplied to push the electron from valence band to conduction band. Now as we know, it's forbidden energy gap of silicon is 1.1 electron volt. So its correct answer will be option B, that is 1.1 electron volt. Now the next question, that is dash is the maximum reverse voltage that can be applied to the p-n junction dash to the junction. Its correct answer will be option A, that is peak inverse voltage is the maximum reverse voltage that can be applied to the p-n junction without damage to the junction. So its correct answer will be option A. Now the next question, 163 number, the flow of a small current during the reverse biased condition in a diode is known as leakage current. Its correct answer will be option D, that is leakage current. Now the next question, what is the resultant charge in a body whenever the number of protons equal to the number of electron in it? Its correct answer will be C, that is zero charge. Means when the number of electron is equals to the number of proton, then the atom becomes neutral and hence it has zero charge. Now the next question is, the electrons in the outermost orbit of an atom is known as valence electron. Now the next question is, semiconductors have dash conduction band and dash valence band. Now as we know, semiconductor have empty conduction band and almost filled valence band, which when provided a fixed amount of energy can reach the conduction band. So its correct answer will be option C, that is an almost empty and almost filled. Means semiconductor has an almost empty conduction band and an almost filled valence band. So its correct answer will be option C. Now friends, in the next video we will discuss the objective questions of the next topic, that is p-n junction diode and diode circuit. That's all. Thank you.